Welcome to our deep dive. Today, we're looking at an article by Anand Ramachandran called Latest Advances in Agentic AI Architectures, Frameworks, Technical Capabilities, and Applications, which came out just last month, March 2025.
That's right. And we're really digging into what's next in AI, specifically agentic AI.
Yeah, it's a step beyond just, generating text or pictures,
Yeah.
talking about systems, intelligent systems that can actually perceive things, reason about them, make plans.
And act on them autonomously. That's the key part. Acting without needing constant human input.
Exactly. It's quite different.
It's a huge shift, really. We're moving from AI that mostly reacts like you give it a prompt, it gives you something back,
Right.
to AI that's more proactive. It can see a goal, figure out how to get there, and then we'll do it.
Yeah.
It's like moving from an assistant you have to constantly instruct to a partner that takes initiative.
And that's what we want to unpack for you today. If you're listening and you want to get a solid, quick understanding of what's really moving the needle in agentic AI right now in 2025, this is for you.
Mm-hmm.
We've gone through this pretty comprehensive article, pulled out the really important bits, the key advancements. We're going to talk about why they actually matter.
Trying to give you those aha moments, right, without drowning you in all the super technical detail.
That's the plan, our mission, really.
And this article, it covers a lot of ground. I mean, foundational concepts, different architectures, the technical frameworks needed to build these things, foundation models like LLMs.
Applications too, challenges, ethics, it's all in there.
It really is quite thorough. So we'll be focusing on extracting the key updates in how these systems are structured, how they're implemented, and what they can actually do now.
Okay, great. And just quickly, if this topic really sparks your interest and you want to explore AI more broadly, you might want to check out the AI Coach by Neil Nathu. Some great resources there.
Good suggestion.
So let's start with the basics. Agentic AI. What really defines it? What makes it different from, say, the generative AI we've heard so much about?
Okay, so the article lays out 4 core properties. First up is autonomy, that ability to just operate and make decisions on its own.
Without constant hand-holding.
Exactly. Then there's intentionality. This means the AI has goals, objectives it's actively trying to achieve. It's not just passively responding.
Got it. Goals. What else?
Adaptability. The world changes, right? So the AI needs to be able to adjust its plans, its actions based on new information or unexpected events.
Makes sense. And the last one?
Reflectiveness. This is about learning from experience, looking back at what worked, what didn't, and using that insight to do better next time.
Okay, autonomy, intentionality, adaptability, reflectiveness. And how does that stack up against older AI or generative AI?
Well, think about traditional AI, often rule-based, very rigid, follows the script, period. Generative AI is amazing at creating content, text, images, whatever, based on prompts.
But it doesn't usually do things in the real world based on that content, not on its own.
Precisely. Agentic AI is about taking initiative, driving actions, achieving goals in potentially complex environments. It's less about creation and more about, well, agency, action.
So it's not just generating a plan, it's figuring out the goal, making the plan, and then carrying it out, adapting as needed. How does it think, so to speak? What are the underlying ideas?
It builds on quite a few established areas. Reinforcement learning is a big one, learning by trial and error, getting rewards for good actions.
Okay.
Then there's cognitive theory, which gives us models for goal-directed behavior, kind of how humans or animals set and pursue goals. And also autonomous systems theory, the principles behind systems that can govern themselves.
So it's pulling from different fields to make this work.
Absolutely. These theories help shape the key components, the building blocks inside these agentic AI systems.
Right, the components. What are the essential parts that make up one of these agents?
You usually find a few core integrated pieces. Perception is key, how it takes in information, and often it's multimodal, meaning it can process different types of data together, like text, images, maybe sensor readings from the real world all at once.
Okay, so it gets a richer picture of what's going on.
Exactly. Then there's reasoning. This is where things like advanced large language models, LLMs, come in. They help the agent understand context, draw conclusions, make sense of the data.
The brain, in a way?
Sort of, yeah. Then planning, breaking down a big goal into smaller, manageable steps or actions, sometimes using techniques like hierarchical planning.
Okay, perceive, reason, plan, Then act.
Then execution, yes, carrying out the plan. This often involves using external tools, calling APIs, accessing databases, controlling robotic parts, that kind of thing.
So it can interact with the digital world or even the physical world.
Correct. And finally, there's memory and reflection. It needs to remember past actions, outcomes, learned information. And the reflection part is crucial for that adaptability and improvement we mentioned earlier.
It learns over time.
Yes. The article actually uses a neat example of an autonomous healthcare management system to show how all these pieces, perception, reasoning, planning, execution, memory, work together in a real-world scenario.
That helps visualize it.
Hmm.
Okay, so those are the core concepts and components. Now, the article talks about architectural innovations by 2025. What kinds of structures are we seeing for these agents?
Right. The architecture is like the blueprint. The article discusses several main types. You've got your single agent system.
Just one AI handling everything.
Pretty much, yeah. All the cognitive functions packed into one system. Good for specific, well-defined tasks. Think of maybe a specialized drone.
Okay.
Then there are multi-agent architectures. This is where you have multiple agents, maybe specialized ones, collaborating.
Like a team.
Exactly, like a team tackling a bigger, more complex problem, maybe managing a computer network autonomously.
Interesting. What else?
We also see vertical architectures, sometimes called hierarchical. Think of a chain of command, agents reporting up, useful in structured environments like manufacturing.
Got it. Top down.
And then horizontal or collaborative architectures. Here, agents interact more like peers, negotiating and coordinating without a strict hierarchy. Maybe for disaster response, where different types of robots need to work together on the fly.
Peer-to-peer.
Sort of, yeah. And finally, and this is a big area of development, hybrid architectures.
Combining the different approaches.
Yes, blending elements. Maybe sometimes it operates hierarchically, other times more collaboratively, depending on the situation. This offers a lot of flexibility.
Okay, so those are the basic types. What were the specific advancements in these architectures mentioned for 2025? What made them better?
Good question. For single-agent systems, the article highlights enhanced cognitive integration. Basically, perception, reasoning, planning, they became much more tightly woven together.
So the agent could handle more complex steps internally.
Right. It could understand and act more fluidly on more intricate tasks. For multi-agent systems, the big thing was advanced interagent communication. They got much better at talking to each other, leading to more sophisticated teamwork.
Better collaboration.
Definitely. In vertical or hierarchical systems, they developed dynamic hierarchical restructuring. The chain of command itself could change based on the situation, making them less rigid.
More adaptable hierarchies.
Exactly. Horizontal systems saw improvements in enhanced peer negotiation mechanisms. Agents became better at working things out amongst themselves, leading to more effective group problem solving.
And the hybrid ones.
Yeah.
You said they were promising.
Yeah, their key advancement was dynamic structural reconfiguration. They could literally change their structure on the fly switch between being more top-down or more flat and collaborative as needed.
Wow, that sounds incredibly adaptive.
It is. The article points this out in the abstract, actually, that hybrid systems really shine because of their adaptability, how well they can scale, and their robustness. They can handle a wider variety of situations.
Can you give a few more specific examples from the article connecting these architectures to real applications?
Sure. So single agent, maybe those specialized autonomous drone operations we mentioned. Multi-agent, definitely autonomous network management, different agents handling security, traffic, load balancing, etc.
Okay.
Vertical, think complex manufacturing lines where tasks flow in a specific sequence. Horizontal is great for something like disaster response, multiple autonomous robots, sensors, drones, coordinating in a chaotic environment.
All right, needs flexibility.
And hybrid, the prime example given is smart city management. You need some top-down planning, but also localized, collaborative responses for things like traffic flow or emergency services. Hybrids fit that perfectly.
That makes sense. Architecture is the blueprint. But how do you actually build and run these things? What about the technical frameworks?
Ah, yes, the frameworks. They're crucial. They provide the tools, the infrastructure, the plumbing, if you will, to turn those architectural designs into working systems.
The practical side.
Exactly. The article focuses on 3 key categories of these frameworks that saw major advances by 2025. First is workflow automation.
Managing processes.
Right, but the advance was in adaptive workflow restructuring and real-time conditional branching. The workflows weren't fixed. They could change dynamically based on what was happening.
Like that healthcare example you mentioned earlier. adjusting patient care flows on the fly.
Precisely that kind of thing. The framework enables that dynamic adjustment.
Yeah, very cool. What's the second category?
Tool calling and API integration frameworks. This is about how the agent interacts with other software or services.
Okay.
The advancements here were around intelligent dynamic tool selection, the AI figuring out which tool or API is best for the current subtask rather than being hard-coded, and also seamless multi-platform integrations.
So it can use a wider range of tools more easily.
Yes, and more intelligently. Think about autonomous financial trading systems. They need to pull data from market feeds, use analysis tools, place orders through brokerage APIs. These frameworks make that smoother and more autonomous.
Got it. And the third framework category?
Intelligent routing and orchestration. This is especially important for multi-agent or complex single-agent systems. It's about efficiently directing tasks and information flow.
Managing the traffic inside the system.
Kind of, yeah. Key advances were in real-time adaptive routing, changing paths based on current load or priorities, and also advanced decentralized orchestration.
Decentralized,
Right.
meaning no single boss directing everything.
Exactly. Agents coordinating amongst themselves more effectively, which makes the whole system more resilient. Autonomous logistics and supply chains are a good example systems that can reroute trucks or adjust inventory levels across many locations without a central bottleneck.
That sounds incredibly complex, but powerful.
It is. And, for listeners wanting to see more concrete examples of how these frameworks are actually implemented in businesses, resources like the AI Coach by Anil Nathu often cover case studies and practical applications.
Good point. Okay, so we have architectures and we have frameworks to build them. What about the underlying intelligence source? The article mentions advances in foundation models, particularly LLMs. How are they improving to support agentic AI?
Right. The LLMs are often the core cognitive engine, as the article puts it. By 2025, several key improvements were noted. Reasoning was a big one.
Better thinking?
Essentially, yes. Enhanced logical and causal inference. Understanding not just correlations, but cause and effect. Plus, better integration of predictive analytics within the LLM's reasoning process.
So they could anticipate outcomes better.
Yes. Think of autonomous investment management again. An LLM that can reason deeply about market causal factors and integrate predictive models would make much smarter decisions.
Makes sense. What else improved in the foundation models?
Multimodal perception capabilities were advancing fast. We talked about agents perceiving different data types. Well, the LLMs themselves got better at fusing and reasoning across text, images, audio, maybe video, all simultaneously.
So the LLM could understand a scene described in text and shown in an image at the same time.
Exactly. And do this adaptively, in real time. This is crucial for things like autonomous robotics or self-driving vehicles navigating complex environments. They need that integrated multi-sense understanding.
Huge for robotics.
Yeah.
Any other LLM advancements?
Yes, domain specialization got faster and better. Rapid fine-tuning methods allowed for creating models with deep knowledge of specific industries like medicine or law.
So you could have an agentic AI with a highly specialized medical LLM inside.
Precisely. Leading to more effective tools like autonomous clinical decision support systems, which the article mentions. Also, real-time adaptability improved.
How so?
Through more interactive and adaptive reasoning mechanisms, the LLM could adjust its thinking process on the fly based on new information or interaction, improving contextual adaptability. Vital for, say, autonomous emergency response systems dealing with rapidly changing situations.
They need to pivot fast.
Absolutely. And finally, efficiency and scalability. Models became more optimized using techniques like optimized neural architectures, making it possible to deploy powerful agentic capabilities even on devices with limited resources like edge devices.
So AI agents running directly on sensors or cameras.
Yes, edge-based autonomous surveillance systems are given as an example. Powerful local processing without needing constant cloud connection.
It's really impressive how these foundation models were evolving to become better brains for these agents. It feels like all these pieces, the architectures, the frameworks, the models, were really converging.
They absolutely were. Each area pushed the others forward.
And again, for anyone tracking these model developments closely, especially how they translate into real capabilities, the AI Coach by Anil Nathu website is a good place to look for deeper dives into specific model advancements.
Definitely a useful resource in this fast-moving space.
Okay, so we've talked about the how the architectures, frameworks, models. Let's shift to the what and why. What kind of impact were these advanced agentic AI systems having across industries by 2025, according to the article? Where were the aha moments in terms of real benefits?
The article highlights broad applicability but gives some really compelling examples. In healthcare, for instance, they mention autonomous ICU management systems.
Autonomous management in an ICU. That sounds intense.
It does, but the article suggests they were leading to tangible benefits like improved patient recovery rates and faster clinical response times, likely by constantly monitoring and subtly adjusting support or alerting staff earlier.
Wow. Okay, that's a significant impact. What about other sectors? Finance.
Yes, finance saw big changes with autonomous algorithmic trading systems. The claim is significantly improved trading accuracy and, importantly, reduced potential losses due to faster, more data-driven decisions.
Faster than human traders, presumably.
And potentially less prone to emotional decision-making, processing vast amounts of data simultaneously. Manufacturing also saw gains.
How so?
Autonomous quality control systems using advanced perception were able to significantly reduce defect rates on production lines, catching problems earlier and more reliably.
I can see that. What about customer-facing applications?
Customer service saw the rise of more capable autonomous chatbots and virtual agents. Not just basic FAQs, but agents that could handle more complex queries, access account information, and actually resolve issues, leading to better customer satisfaction scores and shorter wait times.
So chatbots that actually work.
Getting much closer, yes.
Yeah.
And one more, smart cities. The article mentions integrated public safety coordination.
Using agentic AI.
Yes, coordinating traffic lights, dispatching emergency services,
Yeah.
analyzing sensor data leading to faster emergency response times in simulations and early deployments.
Those are some really concrete examples of benefits. It makes the potential feel much more real.
It does. It shows the technology moving beyond theoretical possibilities into generating actual value. And again, understanding how specific companies are implementing these solutions, that's something resources like the AI Coach by Anil Nathu often explore.
Right, bridging the gap between the tech and the business application. Now, the article isn't all hype, is it? It also mentions ongoing technical challenges. We should probably touch on those.
Absolutely. It presents a balanced view. It acknowledges that, despite the progress, several hurdles remain significant challenges in 2025. Scalability was still an issue for very large, complex systems.
Handling massive amounts of agents or data.
Yes. Real-time adaptability, while improved, still had limits, especially in highly unpredictable environments. Interoperability, getting different agent systems, maybe from different vendors, to work together smoothly remained tricky.
Standardization issues.
Partly, yes. Reliability and robustness were ongoing concerns, ensuring these autonomous systems perform consistently and safely, especially in critical applications. Data dependency was another point. Many systems still required vast amounts of high-quality data. And transparency, or explainability.
Understanding why the agent made a certain decision.
Exactly. That black box problem was still a major research area, especially for complex agents. The article frames these as key areas needing more work, opportunities for future breakthroughs.
So acknowledging the limitations, the frontiers still being pushed, that's important context. And beyond the technical, the article also touches on ethical, social, and governance considerations, right?
Yes, and very importantly so. As these systems become more autonomous, fundamental questions arise. Things like autonomy and accountability. If an autonomous agent causes harm, who is responsible?
$1 million question.
It really is. Fairness and bias mitigation is another huge one. Ensuring these agents don't perpetuate or even amplify existing societal biases present in their training data. Privacy and data protection, especially with agents perceiving and processing so much information about the world and potentially individuals. Then there are the broader social implications.
Like impact on jobs.
Exactly. Employment displacement is a major societal concern that needs careful consideration and proactive strategies. Building and maintaining societal trust in these increasingly capable autonomous systems is also vital.
People need to feel comfortable and safe with them.
Absolutely. And all of this underscores the need for robust governance frameworks and clear regulatory compliance. We need rules of the road for developing and deploying agentic AI responsibly.
It's clear that the technical progress needs to go hand in hand with serious, ethical, and societal deliberation.
The article makes that point very strongly. They're inseparable.
Okay, so bringing this all together, we've covered a lot based on this March 2025 article by Anand Ramachandran. We've seen advancements in the core concepts, the architecture is becoming more flexible, especially hybrids.
The technical frameworks providing better tools for automation, tool use, and orchestration.
And the foundation models getting smarter, more perceptive, and more adaptable.
And all leading to tangible impacts across industries like healthcare, finance, manufacturing, and more, but also highlighting the ongoing technical and crucial ethical challenges.
It really paints a picture of agentic AI in 2025 as significantly more autonomous, adaptable, efficient, and aware of its context than previous AI generations.
That's a good summary. The pace of innovation was clearly very rapid.
And hopefully this deep dive has given you, our listener, a shortcut to grasping these key developments without getting lost in the weeds.
We aim for the core insights.
So, as a final thought to leave you with, consider how these increasingly autonomous systems, as described in 2025, might impact your field, your work, or your interests. What new possibilities could emerge?
And equally, what new challenges or questions might need addressing. It's definitely something worth reflecting on.
Absolutely. Thank you for joining us today for this deep dive.
Thanks for listening.
And remember, you can visit the AI Coach website for more AI insights by Anil Nathu.